Off we go. So good morning. If we close our eyes and imagine the factory of the future, we can all picture a world without paper, a world where everyone has all the information they need at their fingertips every minute of every day. But the reality is, we are such a long way from that right now. My name is Joanne Hedger, and although I've spent 23 years working in manufacturing systems, sadly, I am still yet to walk into a single factory and walk around the factory floor that doesn't rely on Excel in some way or another, pen and paper. And that's despite the interesting and impressive technologies we have available today. We've got handhelds, wearables, smart devices, and despite the progression of Industry 4.0 and the digital age, we still see a surprising amount of strategic operational data being collected on pen and paper on the shop floor. Why is this? What stops us adopting all these new technologies? Why haven't we torn up those line-side logbooks? Why haven't we swapped those whiteboards for widescreens? Well, in order to answer this question, we need to look at the reality of the IT landscape in manufacturing. Starting with the history, of course. The role of IT within manufacturing has been changing for some time now. IT didn't always own shop floor systems. Shop floor systems were owned by shop floor people. They were owned by engineers, quality technicians, and line leaders and supervisors. The data had been siloed by department, and not only by department, but individuals within departments. This end-user ownership meant IT had little or no involvement in shop floor systems. They knew nothing of metrology equipment, machine control systems and SCADA. IT were primarily focused on ERP and office-based applications and infrastructure. But of course, over time, as manufacturing systems become obsolete, unsupportable, or simply not sophisticated enough to keep a pace with manufacturing goals, IT have been called upon to provide suitable replacements, typically on corporate platforms with outsourced support. And quite frankly, the issue with this is that IT teams these days are inheriting a complete and utter mess. I don't know about you, but I wouldn't want to be in IT taking ownership of those systems that are, as we say here, undocumented, unsupported. Where do you start with this? Add to that the changes in technology, add to that IoT, as we've mentioned, add to that mobility, add to that, excuse me, add to that mobility, big data analytics we hear a lot about. All of these things are enabling vast quantities of different types of data to be collected from all over the place, simultaneously. They're all great opportunities, but it makes the task of forming a strategic approach really quite time-consuming and difficult. Add to that the fact that, of course, everyone's a programmer these days. We all have personal websites that we manage. We all have apps on our phones that we're more than capable of doing. There's always people on the shop floor. I can quickly put a solution together to solve that. And of course, IT must manage this. IT must keep abreast of it. When it fails or that budding programmer leaves, IT have to support it. Again, not an easy task. And then, of course, you've got the equipment vendors, people offering vision systems, barcode labelling systems, check weighers. They're all adding value to their offering by putting their own software applications on it, which, again, is all very great and fantastic. But how does that fit in the map on the shop floor of that data? IT used to be guardians of corporate data. Of course, now, IT are having to take ownership of all data, shop floor data, factory data, and that's a mammoth task. That's a big responsibility. And all the while, with all of these dynamics that they're facing, the business are constantly making demands. The business are being driven by customer demands. The business are driven by regulatory compliance, food safety standards. So, of course, every time the business asks for something of the IT team, it's typically urgent. It's typically something that needs to be done immediately. Sound familiar? So, how do we respond? Well, this is a simplified picture of a simple manufacturing processes. It's really not important what's written in each of the boxes, but just to recognise that there are 4 streams here. We've got inventory, production, quality, and engineering, maintenance, if you like. We know these manufacturing processes integrate heavily with each other. We know they're all affected by each other. We look at the connections that go between manufacturing processes. These processes need to be joined up. So, of course, it goes to follow that the systems need to be as joined up as the processes. The data needs to be as connected as those physically conveyors are in the plant. Without data, there can be no automated inter-process transactions. There can be no true real-time visibility. Without data, we cannot enforce conformance to exception processes. People in a business know what to do when exceptions occur, but that doesn't mean they always do it. Business processes are not always followed on the shop floor. But if systems had sufficiently connected data to generate the right insights and actions, exception processes could be enforced. But in reality, of course, the systems picture is a very long way from matching the manufacturing process picture. We all probably have seen this pyramid of software systems in manufacturing before. It represents the layer of software. At the top, we have our business systems, your SAP, your Oracle, and the like, typically focused on finance, driven by daily and weekly figures, typically quite rigid, quite standardised. And then, of course, you have the middle layer, the plant operations applications. And as I say, this picture is a long way from being standardised. In here, we have a mass of point applications, all from different ages, all from different vendors, on different platforms and technologies. And increasingly, they need costly integration just to analyse or report the data that comes from them. Of course, over time, with haphazard quick fixes by budding programmers, this layer has grown into what can only be described as spaghetti plumbing. And no one sees the whole picture. The whole time these applications are all separate, independent, no one ever has a hope of seeing the whole picture. In this world, your CMM or your maintenance system might tell you one thing. You've produced a number of, you're constantly repairing faults on a particular asset. But your quality system might be telling you you've got consistent defects coming from a particular line or process. With the two systems not talking to each other, no pattern can be spotted. Everyone could be busy solving the wrong problem. So we need a strategy to bring this together. Quite in short, we need MES. We need manufacturing execution systems. We need a single, holistic approach designed to be as flexible as manufacturing. Since this data is what's going to make the difference, this data is going to be the thing that makes that 6% improvement, it's absolutely vital that this data is not only collected, but put to work. Firstly, of course, it should be available and accessible to everyone. It needs to be accurate and timely, of course. It needs to be collected once and used many times. You don't want people entering the same data into a number of different systems over and over again. It should be shared amongst the owners and used to empower the people who can actually do something about it. It should be contextualised. No one has time to sift through vast amounts of data finding the bit that's important for them. The system should tell them what's important, and it should make it obvious. But above all, the data needs to have meaning, so that it can be exploited later on for greater gain. So what do we mean by that? What do we mean by exploiting data? Well, MES, manufacturing execution systems, aren't just about replacing 20 applications with one. They're about having a consistent set of data on which to base decisions, connected data. They're about having a consistent set of data to analyse for continuous improvement purposes. It's about adding to the meaning to the data in terms of insight and then subsequent actions. MES data is used to deliver awareness, enforce business process, drive improvement. It's not just about making failures in the factory visible to everyone. Put some examples here of where connected data can actually help. An operator enters a downtime reason, which is a breakdown. MES would automatically trigger a repair request. Quality defects repeatedly appearing in a process might automatically trigger some maintenance activity, a service on the machine perhaps. Adjustments to the job schedule would be made automatically as a result of live downtime events or material shortages. This is smart manufacturing. To get this connected, to get this smart on the shop floor, requires a single MES platform. But with a scope as wide as this, of course, we've got all sorts of functionality here. That can be quite a daunting project. It's a massive step. So whilst it's great if you can do it all in one go, if you can't, you can take a step-by-step approach. Now, where you start that step-by-step journey depends on a number of factors. You might start with something very, very small. That step could be any one of these typical manufacturing functions. You might start by reporting production figures, downtime or waste. Or you might move into inventory and start tracking jobs, raw materials, or finished goods. You might start with the quality department, manage non-conformances, complaints, or perhaps a drifting process. Or finally, you might start in asset management, looking at proactive and reactive maintenance activities, repairs, tool tracking. The more modules you add, the more data you capture, the richer the picture of your factory. And when you get to this point, you can start to do seriously intelligent things. So in the short time we have remaining, I'd like to share with you an MES journey of one of our customers. I'm hoping you'll be able to guess who the manufacturer is I'm talking about. They produce some of Britain's best-loved biscuits. With over 180 years' experience and 11 factories across Europe, they sell into almost every household in the UK. They are, of course, the makers of the Jaffa Cake, the Hobnob, the Rich Tea and the Penguin, the Club, the Ginger Nut, and, of course, the amazing Digestive that we all know so love. So this is a company with a string of awards. This is a company dating back an incredible number of years. So let's start with having a brief look at the process of a typical production line at United Biscuits. Firstly, raw materials arrive, turned into dough in the mixing plant, which feeds the primary process, typically baking. Baking is followed by an optional secondary process, my favourite, chocolate coating. Process typically splits into a number of packing legs then, each now packing a different SKU. And these in turn are packed in secondary into cases, multi-packs and pallets. And then, of course, before they're loaded onto trucks for shipping. Now, UB's first foray into the world of MES was some years ago now. It was a pilot project on a single line, much like this. Unfortunately, it didn't go so well for a number of reasons. But, of course, undefeated, they started again with a different approach and a different vendor. And so it was that they started working with Lighthouse in 2009. So after their initial MES failure, they started by forming a steering group, very important, which comprised the manufacturing director, finance, a number of key management functional leaders, and of course IS. The starting point for the second attempt was a project called OLP, Overall Line Potential. And this particular project began when the manufacturer said, what I want is a single KPI. I want to see performance against potential. But I want to see it across all lines, across all factories, so we can look across the whole business and see how we're performing and what the opportunities are and where we can identify our losses. Be they unplanned stops, be they waste, be they slow running, speed. But of course, if we're going to do it across the whole business, we need to keep it simple. So we said the requirements are, I want to have everybody measure the same KPI. I want to have the same people collect the same data in the same way on every plant. I want to have the same people use the data in the same way. In this case, it happened to be the line leaders. And I want to view the data in the same reports, which must be first at a line level, and then the exact same report rolled up to a plant level, and again, the exact same report showing me a global level across all 11 factories. I want to start collecting it manually. I want to collect it as we go. I want everybody, certainly at the end of each shift, to be collecting this data. But there must be simple reports where we can identify the losses in terms of availability, speed and quality so that people can actually act on it. I also want it driven by our local people. People responsible for this project are going to be the people at the plants responsible for continuous improvement. So what they wanted was, on the face of it, quite simple. But of course, it had to be scaled up to 188 lines. It also had to be deployed on a central server so that people could remotely gain access to the information. So having gone through a pilot that didn't work so well, they now said, let's do something much, much simpler, but across the whole business. Get some real data on which to measure ourselves and to make improvements. That was the ambition. So in the first phase, we look back at their manufacturing process, and you see the red dotted line there is a very, very tiny scope. The first phase, we were only looking at tracking each production run and recording output in cases and kilos, tracking what the waste was, and recording downtime that had occurred on the lines, duration and reasons. All manually, so of course there were question marks around the accuracy of the data, but fundamentally, this first phase for United Biscuits was like turning the light on. Let's just come back there, sorry about that. Nobody had ever seen the full picture before. The The full picture across the entire business, from top to bottom, suddenly became visible to everyone, and it had an absolutely transformational effect on the business. So what did it look like? Well, we started by creating a simple dashboard to their requirement, showing firstly in the top left quadrant a history of the OEE performance. Then followed by 3 more charts showing more real-time data, starting with analysis of losses, where we have in the top right a portion representing the OEE achievement, and then other portions representing what the losses, the contributing factors to those losses, where they speed, where they waste, where they unplanned stops. Then, of course, we can look down in the bottom left in more detail at the downtime, identifying the root causes of the downtime. Was it process side? Was it packing side? With MES, they now know which machines caused which stops, and the same for waste. Where is it being generated and why? It was simple, very, very effective. It was the first time the business had visibility, not only of the performance of the lines, but the opportunity for improvement. In the past, they'd have a lot of people doing a lot of different things, but this project was the first time they'd done anything on a global scale in a consistent way. So now that the core platform was in, albeit only a small part of it, and following the success and the momentum of the OLP project, we mapped out phase 2. And the business had various issues in phase 2 that it was looking for solutions to. But of course, they already had the core platform in, so by building on that shop floor online MES, we were able to use the same software, the same infrastructure, the same servers and database. We were able to provide the same delivery to users in a very, very short space of time. The look and feel of the system was the same to everybody, so the adoption of the system by the plant operations team was very straightforward. And of course, we made the IT team look great. We made them look really agile. They were able to respond to business needs in a very short space of time. A few just listed some of the phase 2 projects that went on there. Finished product quality assessment. They basically went out to retailers, bought packets of biscuits, and then did quality checks based on quite strict quality controls, looking at everything from packaging, taste, were the biscuits in good order when they arrived. We also looked at process parameters for the process engineers. They wanted to look at process dynamics. They were able to do this now remotely. And we also had to automate a scorecard where data was sent up to SAP, to their business ERP system. MES already had this data now, so we were able to automate that process and feed SAP the data it needed. So phase 2 was about adding more data to the system for the benefit of additional departments, and of course starting to do this automatically where possible. So where phase 1 was nice and simple, we put dough in one end, we counted kilos of biscuits out the other. Phase 3 needed to go down to a much more granular level. We needed to look at the data by SKU level. Each line could be packing more than one SKU at the same time, so the level of complexity was far higher. And of course, with this higher level of complexity, it was very clear that the data could no longer be connected manually. Automation would make it feasible, as well as bring added benefits, higher levels of accuracy. You'd be able to validate raw materials with the right raw materials to be used. However, this would take a lot of investment, particularly as they had 188 lines. Automating on that level was going to be a huge investment. However, United Biscuits wanted to take the platform to the next level, and they decided some lines were more profitable than others, so they decided to target the project to only their high-value lines. We implemented first on a pilot at their largest site in Harlesden, and then once proven, it was rolled out to other high-value lines across the business. It quickly gained momentum, became known as Project Showroom. The scope was to automate as much as possible. Automate the case counts, measure turn of scale, giveaway, using inline check weighers, and also to track inventory that hadn't yet made it into SAP that might be held back in the plant for quality reasons. So this is what the plant looks like now. Here we see a view of the end of the secondary packing legs, where they have large MES dashboards real time on screens, enabling and empowering operations to improve reaction times, actually affect the line KPI. So with phase 3 well underway, Project Showroom now being rolled out across high-value lines, United Biscuits continued their MES journey. Phase 4 started looking at replacing legacy maintenance management systems. Then they started looking at energy, and this is where connected data really made a difference. Energy has some great potential because MES had accurate knowledge of production volumes. So now we could see how much energy was used to produce a kilo of biscuits, energy per part, energy per shift, energy per pallet. And of course, with the downtime data also in the system, we could look at energy that was being consumed when the plant was making biscuits and compare it with how much energy was being consumed when they weren't making. Looking to the future, United Biscuits are considering the next step on their journey, which is likely to be around production scheduling. This holistic approach, broken into manageable sized projects, has been a big win for their business. MES has proven its worth at every step. Now, of course, I'm running out of time now, and I need to bring this presentation to a close. So I have one slide remaining, which summarises the benefits of an MES approach from two perspectives. I'll leave them up there so you can have a read. When I started this talk, we thought about how we imagined a paperless factory of the future, pictured how good it would be if the right people had the right data at the right time, all the time. But then we looked at the obstacles we faced in achieving that, and it seemed a mountainous climb to get there. But then we looked at how a world-class food manufacturer is achieving that utopia one step at a time, with one system on one platform and highly connected data. And with MES, it really is achievable. So feel free to come talk to us. Come, bring me food, please. Thank you very much.